Welcome to GER Hub Mathematics and Statistics lessons. In today's video, I'm going to be talking about the determinant of a 3x3 matrix by the method of Sarrus. The determinant of a 3x3 matrix by the method of Sarrus. Before I begin, let me say a very special thank you to all our subscribers. Thank you for subscribing to the channel. Thank you for your likes to our video. Thank you for your shares of our videos. Thank you for watching and viewing our videos. We are very, very grateful. Thank you for spreading the word about our channel to people. Thank you for all these you have done for the channel, for your support. Thank you also to those who have not subscribed to our channel yet, but they have been viewing or watching our videos. Please endeavor to subscribe to the channel. That being said, now let's begin. So, the determinant of a 3x3 matrix can be obtained using a method called the method of Sarrus, okay? Or the method of Sarrus. Now, how do you use the method of Sarrus? This would require us to look at a 3x3 determinant again and certain concepts we had earlier discussed on matrices, okay? A 3x3 matrix and certain concepts we have discussed on matrices. So let us see. Now, let us put quickly, let A be a 3x3 matrix, okay? So let A be a 3x3 matrix. If A is a 3x3 matrix, then we can actually write A in this form: A11, A12, A13 as the elements of A, A21, A22, A23 as the elements of A in the second row, A31, A32, A33 as the elements of A in the third row. Now, if this is the matrix A, what we want to obtain is the determinant of A. Remember, this is the notation for the determinant of a matrix by putting the matrix itself in between two straight lines, and this is DETA. So what we want to obtain is this. What would be the determinant of A? That is, in this case, this 3x3 matrix. So what we are going to do is to introduce the method of Sarrus. But before we introduce the method of Sarrus for doing this, let us see. Now, this is the principal diagonal of the square matrix. It is a diagonal that runs from the topmost left element down to the bottommost right element. Okay? So this determinant, diagonal, the principal diagonal, is the diagonal that runs from the topmost left element, that is this element A11, to the bottommost left element A33. There is also another diagonal, that is this one, the auxiliary diagonal. Now, this diagonal is different from the principal diagonal because, unlike the principal diagonal, the auxiliary diagonal runs from the bottommost left element, this one, A31, straight to the topmost right element. Okay? Now, please hold on to that idea. We shall be using the idea for obtaining the determinant of a matrix, a 3x3 matrix, using the method of Sarrus. Okay? So, what is Sarrus's method all about? Now, for a 3x3 determinant, I'm going to add a sprinkling of my idea for going about this to make it easy for you to compute the determinant using Sarrus. Okay? I'm going to sprinkle my idea on this. Now, what I would suggest you do is to put up these. Okay? So you can put up a box, a rectangular box, and split it into two, such that the two parts of this rectangle, you can call this part a main block of the elements, and you can call this one an auxiliary block or secondary block of elements. Okay? Now, for using the method of Sarrus, bring all the elements as they are in the 3x3 matrix. Bring all these elements: A11, A12, A13, A21, A22, A23, A31, A32, A33. Bring all these elements the way they are in the 3 by 3 matrix, bring them here. Then bring all the elements again the way they are in the 3 by 3 matrix, bring them here again. Repeat them in the auxiliary block, okay? So I'm going to bring A11, A12, A13 here, A21, A22, A23. I'm going to bring that here, and I'm going to bring A31, A32, A33. Now notice that I am repeating the elements as they are in the matrix in the two blocks. One set will be in the main block, and the other one will be in the auxiliary block. Now, when you are done doing that, you will start from this point, start from this element here, the topmost left element in the main block. Start from there and take this diagonal, the principal diagonal, okay? Now, after taking the principal diagonal, because it is a 3 by 3 matrix, take 3 more principal diagonals that go in that direction. That is 1, 2, and then take a third one, 3, okay? Now, when you take the 3 of them, because it is a 3 by 3 matrix, so this is where you start from. Start from the topmost left element in the matrix, okay? When you do, take this one, the principal diagonal, take the one that looks like the principal diagonal that follows next, take the next one that looks like the principal diagonal also, and finally this one, okay? So take these 3. Now what do you do with them? You will now say DETA, otherwise written as this, is equal to, take the product of the elements in the first principal diagonal, A11 times A22 times A33, okay? Add that result to the next one, okay? So let me bring it over here. Let me bring what I'm doing over here. So I'm going to bring all this, okay? Let me bring what I'm putting over here. So when you have done this, taking these 3 principal diagonal, because it's a 3 by 3 matrix, do this. Take the determinant of A, written as this or this, to be in one box now. The product of A11, A22, A33, put it here. It will be A11, A22, and A33. That is the product of the elements in this first diagonal. Now, add that result to the product of the elements in the second diagonal, A12, A23, A31. Then add it to the product of the elements in this last diagonal, which is A13, A21, and A32, okay? Then close your bracket. Now, when you do that, put a minus sign and go back to the diagram. Now, remember we started from here to take the principal diagonals, 1, 2, 3. For you to get the auxiliary diagonals, you will start from there, from this one here, okay? The bottommost left element. So, take also 3 auxiliary diagonals, 1, starting from the bottommost left element, 2, and then proceeding 3 steps to this point, 3, okay? Repeat the same procedure in this bracket here, the next bracket that follows after the minus sign. So here you would multiply A13 by A22 by A31 and add that result to multiplying A11 by A23 by A32. Add that result finally to, add the result finally to the last set of elements in the third diagonal, A12 times A21 times A33, okay? So that is what you are going to have. You are going to have this. Now, when you do this, what you are doing is otherwise using the method of Sarrus. Notice for the method of Sarrus, form 2 main blocks, 2 blocks, such that one is called the main block and call this other one the auxiliary block. Bring the elements as they are of that matrix into the main block and put them also in the auxiliary block. When you do that, take first of all 3 diagonals, because it is a 3 by 3 matrix. So if it were to be a 4 by 4 matrix or a 5 by 5 matrix, you'll be taking 5 for a 4 by 4 matrix. You would have taken 4 diagonals starting from here, as principal diagonals, and you would have taken 4 diagonals starting from here as auxiliary diagonals. But since it is a 3 by 3 matrix, start from here to take 3 diagonals. 1, 2, 3. Now, along each of these diagonals, multiply the elements, add the result to multiplying these elements here, add the result to multiplying these elements, okay? Then subtract, put a minus sign, and then repeat the same procedure for the auxiliary diagonals, 3 of them, 1, 2, and 3. You multiply the elements along the first auxiliary diagonal, add the result to multiplying the elements along the second auxiliary diagonal, and then add the elements to multiplying the elements along the last auxiliary diagonal, okay? And that will give you this. So this method is called the method of Sarrus. It will give you the determinant of the matrix. Now we are going to confirm that result. We are going to use an example to explain this and then confirm it using the alternative method I discussed in my earlier video to show that the determinant will be the same, okay, irrespective of the method. So let us see. Now what if, let's take an example. So if I have a 3 by 3 matrix A, for instance, that is 1, 4, 2, 1, 0, 1, 1, 2, 1, 4, okay, this matrix. Now I want to obtain the determinant of A. Let's see. So if we were to obtain the determinant of A using the alternative method, that is the previous method I had discussed in my video, you watch out for that. You just go back to my video on alternative method for obtaining the determinant of the matrix and watch that video. If you were to obtain the determinant of this matrix using the first row elements, this would have been 1 in bracket 4, 2, 1 in bracket 0, the minor of this, 0, 1, okay, 1 and 4. That is this. The minor 1, this element here times its minor. Then minus, since we are using along the first row, so minus 4 times the minor of 4, which is 1, 1, 1, 1, 2, 4, 1, 1, 2, 4, plus the last element here, 2. Remember, we are trying to obtain the determinant along the elements of the first row, okay? So that will be 2 times 1, 0, 2, 1. Now, why am I doing this? I'm using the alternative method here to get a result for the determinant so that we can now use the method of Sarrus to implement the same determinant such that when we get the result, we now compare, okay? So this is 1 in bracket 4 times 0 is 0 minus 1 times 1 is 1. Now, for you to understand what we are doing here, quickly go to my video on the alternative method for obtaining the determinant of a matrix or a 3 by 3 matrix and watch that video extensively. You would understand what is going on here, okay? So this is 1 times 4 gives 4 minus 2 times 1 gives 2 plus 2 into bracket 1 times 1 gives us 1 and 2 times 0 gives us 0. So this is 1 minus 0. Now if you simplify, 0 minus 1 will give us minus 1. So this will be 1 times minus 1. Here you would have 4 minus 2 gives us 2. So this will be 4 times 2 plus 2 into bracket 1 minus 0 is 1. So this will give you 1 times minus 1 is minus 1. Minus 4 times 2 is minus 8. Plus 2 times 1 is what? Is 2. Okay? So the result becomes minus 1 minus 8, which is minus 9. Minus 9 plus 2 will give us minus 7. So the determinant of this matrix is minus 7. Now, let us now use the method of Sarrus to obtain the determinant of this matrix. If we were to use the method of Sarrus, the reason why we are now using the method of Sarrus is to show you that the method of Sarrus should give you the same result as what we had obtained using the method of the alternative method, using the alternative method. So what does the method of Sarrus require? So I'm going to form a main block of these elements. 1, 4, 2, okay, 1, 0, 1, 1, 0, 1, 2, 1, 4, 2, 1, 4. And I'm going to repeat the elements here. 1, 4, 2, 1, 0, 1, 2, 1, 4. Okay? Now, according to the method of Sarrus, we are to start from this element here, taking the first principal diagonal, taking the second one, okay, and taking the third one. Now, when you do that, that will give you in one bracket 1 times 0 times 4 plus 4 times 1 times 2 plus 2 times 1 times 1. So 2 times 1 times 1. Okay, you close the bracket and subtract. Go to the next bracket and then take the auxiliary diagonals. Okay, now if you take the auxiliary diagonal starting from this one, this will be the first auxiliary diagonal starting from this element here, 1 followed by 2 and then followed by 3. Okay, so in the first auxiliary diagonal you have 2 times 0 times 2 plus 1 times 1 times 1 plus 4 times 1 times 4. Now let us simplify and see if we will get the same result. So on the next line, I'm going to write here. Now 1 times 0 times 4 is 0 because 1 times 0 is 0 and 0 times 4 is 0. So this is 0. Now plus 4 times 1 times 2. 4 times 1 is 4. 4 times 2 is 8. So this is 8 plus 2 times 1 times 1. 2 times 1 is 2. 2 times 1 is 2. So this will be 2 here. Minus. Then come to the next bracket. 2 times 0 times 2 is 0 plus 1 times 1 times 1 is 1 plus 4 times 1 is 4. That 4 times 4 is 16. This will give you 16, okay? Now, if you simplify further, 0 plus 8 plus 2 will give you 10, and 10 minus 0 plus 1 plus 16 will give you minus 17. So you end up having your result as minus 7. Now compare the two, you will notice that the method of Sarrus would actually give you the same result as the alternative method. Thank you very much for watching this video. It is a short video that teaches you how to use the method of Sarrus for obtaining a 3x3 determinant. And I am really grateful you have watched this video. Thank you very much. Thank you very much. And thank you very much.